Hello my dear students, welcome back to NEET World. So in this particular session, we will be discussing the previous year questions of NEET, JEE and EAP set from different chapters. So let us see here, the first question is from chemical kinetics. So what the question says here is, for the first order reaction A gives rise to B, the half-life is 30 minutes, the time taken for T 75%. So T 50% is 30 minutes and they are asking for what is the time taken for T 75%. I mean time taken for 75% completion of reaction is how many minutes they are asking. Very simple. So for example here, for first order reaction initially I have 100. So now how much it is over here? See, for first order reaction for T half, I mean half life. Half life means this 100 becomes initial concentration, I am saying 100 let us say. So half means it become 50 right now, and it is also mentioned 75. It means again it should become what? 25 here. Okay. So half of this. So this is 1 T half I can say, and from here to here one more T half I can say, and from here to here what I can say, see 100 becoming 25%, 25% means what I can say, T 75%, 75% is completed. So I can say the time during this process as T 75% right now. So now I can say T 75% equals to how many T halves are required here, see 1 T half and a second T half. So simply I can write 2 T halves, that's it. So use this concept to solve this question, and T 75% equals to 2 times of T 50%, that is 30 minutes. Right now, so 30 minutes. So what is the answer for this? Just 60 minutes will be your answer. Hope this is simple and clear now, right? Okay. So similar to this, I will be asking you few more things here. So if T 75% is 30 minutes, then T 50%, what you should do, just take by 2, T 75 by 2 gives T 30, T half, that is T 50%. Or simply I can also ask the other question here is, see if T 50% is 30 minutes, if T 50% time required for 50% is 30 minutes, then what is the time required for T 90%? What is the time required for T 90% and T 99%? So what is your answer? Tell me in the comment box for these two questions. Okay, very simple, you just give a try. Okay, based on this approach, See if I say further, one more T half I will get here 12.5. So like this you keep on taking, so that you will get some relations for T 90, T 99 or T 99.9%, something like that. Okay, so try all these questions, whatever the homework questions I have mentioned here, practice questions. So now we have one more PYQ here. The stepwise formation of copper complex here is given below. The value of stability constant K1, K2, K3, K4 are also mentioned. Then the overall equilibrium constant for dissociation of this complex. See, they have given formation reaction and they are asking what is the dissociation constant for that particular complex formed in the reaction. Very simple, look at here. First of all, find what is the constant, rate constant or equilibrium constant for formation of ammonia. So for formation of this particular complex. So this complex formation is taking place in multiple steps now. So 1, 2, 3, 4 steps are involved. So the resultant complex is forming from where it is forming. So just look at here. See, I can remove this one and this one and this one and here and this one and this one. Like this if we remove, what is the final thing we are having here? Cu plus 2 plus 1, 2, 3, 4. So 4 ammonia molecules here. Okay, ligands I can say here, and giving rise to complex. Our complex is CuNH3 4 times plus 2 charge. So this will be the complex. So for this I can say constant as K total, so as K. Okay, so K is nothing but here just multiplying this all 4 equations we got this right now. That's why reactant or product are getting cancelled out. In the first step product, second step reactant are same, that's why I am removing them, okay, cancelling out them. Therefore K total, K overall for this particular complex will be K1 into K2 into K3 into K4 you should take. Okay, so that's it. So what is the K overall we will get here? So K overall equals to, what is the K1 mentioned, that is 10 power 4. So take here 10 power 4 multiplied with K2 is how much? 1.58 into 10 power 3, and K3 is 5 into 10 power 2, and K4 is 10 power 2. Like this you take, and then next how many 10 power 4s? Here 10 power 4, 10 power 3 means 10 power 7, and 10 power 9, 10 power 11. So 10 power 11 here we have, and 1.58 into 5 we have. So from this what we will get? 0, 4, 25, 9 into 7, 7.9 into 10 power 11 we got here. So this is K overall for formation of the complex, right now this is for formation of the complex. Now they are not asking for a formation complex, they are asking for dissociation constant. It means reaction should be reversed. So if reaction is reversed, it means what I should write? So Cu NH3 4 gives rise to Cu plus 2 gives rise to Cu plus 2 plus 4NH3. So this is what we should write. It means the reciprocal of this. So if reaction is inverse, an equilibrium reaction is reversed, then its equilibrium constant becomes inverse or reciprocal. Okay, like this. So what is our K overall here? That will be 1 by K dash will be equals to 1 by K overall. So that is what our answer here. So K dash equals to, this is for dissociation, equilibrium constant for dissociation, that is what they are asking. So 1 by 1.9 into 10 power 11 you can write, and this simply I can write. So 10 power minus 12, here 10 and here 7.9. So this will be around 1.2 something like that into 10 power minus 2. So what they are asking, the nearest value, round off to the nearest integer for value of x. So what I can say in the given format. So x can be 1 I can write, because nearest integer is only 1 into 10 power minus 12. So what is our answer here? 1 will be your answer. I hope this is also clear, right? If these are clear, just click on the like button and we'll move forward with few more questions. Now hope it is clear. Now I will be giving you one more the basic understandable question here. Try this and tell me your answer. So A gives rise to C, B I can say, and B gives rise to C, and C is giving us D. Then what is the equilibrium constant for this reaction A to D? Okay, so for this I am saying K1 which is equals to 10 power 2, and for this K2 equals to 10 power 3, and for this K4 equals to 10. Okay, so like this I am giving. Then tell me K overall. What is the value of this K overall in the comment box? Very simple now, right? Okay, yeah. So if you are able to understand this concept, then this question is easy. Okay, so what I told you, so in order to get this, see, we can remove the reactant in one reaction and product in the other, like this, so that finally we are having only these two things. That can be comes from the multiplication of these three things, then their equilibrium constants also multiplied to get this K overall. That's it. Okay, right. Let us move forward. See, when I minus is oxidized by KMnO4 in alkaline medium, so I minus converts into which form? See, this is J20 like 2004 question, similar question, similarly this I minus only came in the recent J advance also. Okay, so the question says here KMnO4 is used to treated with this I minus, okay, in alkaline medium. So what happens here? So manganese convert into like Mn plus 7 converts into Mn plus 4. So we will get MnO2 type product, and this I minus is there now. So that will be converts into iodate, like IO3 minus. Like here potassium is there now. KiO3 will be the product formed here. Okay, so means this will be the product here, iodate. So first option will be your answer. Hope this is clear. Again, just remember, whenever manganese here taken in basic medium, here we got its oxidation status plus 4. Okay, if the reaction is taking place in acidic medium with the KMnO4 and any other things, okay, this is an oxidizing agent now. So these oxidizes others and itself reduces to Mn plus 7 to Mn plus 2. Okay, in case of acidic medium. Okay, the reaction here mentioned in basic medium or alkaline medium, that will be the different case as shown here. Okay, yeah. Someone in the comment. Sayad, Shahid in the comment box. Yeah, hi my dear. So I just wanted to tell you is please follow the class, and if you have any doubts you can ask me here. Yeah, next here we have the bond present in N2O5 is. So N2O5 is a oxide, nitrogen oxide. What is the oxidation state here? See, in the last previous session also I have given some explanation for this kind of question. See, 5 oxygens are there. If you find the oxidation state here, you will be getting +5 for each of the nitrogen atom. See, maximum oxidation state shown by the nitrogen atom is +5 because it has like NS2 NP3 electronic configuration, 2s2 2p3. So 5 valence electrons, so it can lose all these 5 electrons and become +5 oxidation state. Okay, so now whenever a central atom is in +5 oxidation state in their oxides, there exists one oxy bond like O bond between two central atoms like NON kind of bond. Okay, if this oxidation state, the calculated oxidation state is like greater than the maximum oxidation state of the central atom, then there exists peroxy linkage. Okay, like that you should understand. Now we have here nitrogen and nitrogen having oxidation state +5, therefore there will be having one NON kind of linkage, oxy bond will be present. Okay, and along with this, so here I am writing one oxygen over here and the other one here. Okay, so nitrogen can form maximum of 4 bonds only because it has one 2s orbital and 3 2p orbitals. So it means how many orbitals are there in overall here in the valency of nitrogen? Only 4 orbitals, no? So that it can make only 4 bonds because each orbital can accommodate only 2 electrons, no? Like that it can accommodate 8 electrons, each one with the 2 electrons. It means 1 bond as 4. Okay, now already 3 over, the 4th one bond will be day 2 bond here. Okay, this side also one more day 2 bond like this. Okay, this is the structure. So you have covalent bonds in this as well as coordinate or dative bond, coordinate covalent bond. So what is our option here? So option B will be the very suitable answer for this particular question. Okay, right. So let us move forward. Under the ambient conditions, the total number of gases released as a product in the final step of the reaction scheme given below. Okay, this is the reaction scheme given below from J Advanced 2014 I have taken. So XeF4 upon hydrolysis produces, so upon complete hydrolysis produces XeO3. What is the oxidation state here? +6, na? So here also you will get +6 oxide here. Okay, we got this, and along with that 6 HF molecules are formed. Okay, so what is our P? So our P here is XeO3. So this XeO3 upon treating with basic alkaline medium, so what happens, it will be added, this OH group will be added and giving us XeO4 H XeO4 minus. Okay, so this one will slowly decomposes undergoes disproportionation to form Xe as a product and XeO6 minus 4 plus H2O as well as O2 gas is released during the process. So we know O2 is a gas and xenon here which is formed as a single the state as Xe0 oxidation state, this itself is a element here. So now these are the 2 gases produced here. What they are asking, the total number of gases released here. So this is one and the other one is O2. So what are the products in the gaseous state? Only 2. So option 2 will be your very suitable answer for the question. Okay, right. So let us move forward. So just solve this question. The spin only magnetic moment value for the complex, this is the given complex and asking what is its spin only magnetic moment. So how can we do this? Very simple. So first take the complex, find the oxidation state of the central metal atom here. So cobalt here is having +2 oxidation state. How I am saying +2? Consider cobalt oxidation state as X that value we need to find. 6 cyanide ions are there, 6, each one is having -1 charge. It's a monodentate ligand, cyanide ion, so -1. And what is the overall charge present over the bracket here? -4. Take it as equals to -4. So X will be -4 plus 6. So oxidation state is how much for the cobalt in this complex? +2. Like this we need to calculate. So we know cobalt atomic number is 27, okay, right now. So it will be having 3d7 4s2 electronic configuration in its elemental form. But what is the oxidation state in the complex? +2 now. So remove 2 electrons from here, okay, in the +2 oxidation state, remove 2 electrons from 4s, okay, 4s orbital. Okay, after that we have only d orbital electrons as 3d7. Now these 3d7 electrons, will split into different energies, okay, 1 2 3 4 5 6 7 electrons are there, okay. So now what happens here, I can explain this with CFT as well as VBT also, okay. These are the 7 electrons we have. And what about the ligand attached here? Cyanide ion, which is a strong field ligand, right now, strong field ligand. So this strong field ligand, what it will do is, it will pair up the electrons here in order to get the more stable sharing of electrons, okay. So if it is paired up, so what happens here, we have one box here, that is what I can say that as empty orbital here right now. So what is the oxidation state here? +2 we have, this will be the case, okay, in the case of +2. So this electron will be paired up, and this is 3d, and we have along with this we have 4s, after this we have empty 4p also, this is 4p, okay. If this pairing takes place, what we are going to get? We are going to get, see, it is an octahedral complex, 6 ligands are required here, okay. It means 6 ligands need to pair up here. It means how many empty orbitals are required? 6 empty orbitals are required. So is it possible? Already we have 4 here. So if I pair up these, we will only get 5th one, but we won't get 6th one, as 6 empty orbitals are required. Therefore there is no use of pairing here, okay. So now what happens is, this will remains as it is, this remains as it is. It will be uses this 4s, this 4p, 4 over, and again we have here 4d, right now. So 4d, so it will be using these 6 orbitals. Therefore what is the hybridization we are going to get? sp3d2. So sp3d2 hybridization, and outer d orbital is used now. So outer orbital complex you can say. Now how many unpaired electrons are there here? How many unpaired electrons are there? So 3 unpaired electrons in this case. So if 3 unpaired electrons, our magnetic moment value will becomes equals to root over n into n plus 2 Bohr magneton. So this can be 3 into 3 plus 2. So I can say 5, okay. So root 15 will be your answer here, okay. So now root 15 I can also write it as 16 means, root 16 means 4 we can write now. So this will be around 3.9 Bohr magnetons. So this is what the answer you should take in the question, okay. Okay, and after this look at this. In the following sequence of reaction, the major products B, C respectively are, okay. So we have this, the reaction mentioned with reagents here, okay. So what happens to this alkyl halide? Like we have Br and chlorine here right now. So by looking at the products, I can say whenever we treat this with sodium in dry ether, so what happens? Woods reaction takes place. In Woods reaction, what happens? We will be getting the alkanes as a products, okay. Here bromine are in there, chlorine is there, but you know bromine containing groups are more reactive, therefore this will be comes out first. So if we have these molecules as 2, so they will pair up and they will be giving this chlorine remains as it is here, like this. So this is our A I am taking, okay. So to this A, if I add COF2, so if you add this cobalt difluoride, so what happens is halogen exchange takes place. This chloride comes out and fluorine goes in, okay, in the both cases, this side and that side, so that we will be having a product like this side also, okay, and this is our C, okay, and what is our B here? See, whenever we treat this with magnesium, what happens? It will be converts into Grignard reagent right now. So Grignard reagent is formed here, both halogens are converting into MgCl, okay, this side also MgCl, okay. So these upon treating with D2O, D2O means deuterium water, heavy water we can say. So now, these classes are live every day. From morning I will be taking, and followed by physics and followed by biology if you are student of NEET, and you also have mathematics class at early morning 6:30 itself if you are preparing for JEE, okay. Now look at here. So what happens? This is a Grignard reagent goes out, okay, here creating negative charge in the carbons right now. So from this D2O we have D plus and OD minus right now. So this D plus will be inserted here and we will get a simple nucleophilic addition here, D here. So this kind of product is formed here. So where do we have these two products? B, this is B, okay. So look at the options, see here we have B here and C here. So option A will be perfect answer as we got C, D here, C, B as the first option, okay. So this is a scenario, and there is one more type of product formed during the reaction, but they haven't mentioned that in the options. Therefore we should go with the suitable answers given as per the options. So these two are the correct, okay. Now if the option doesn't contain this, then what is our expected answer? See, the expected answer will be if this is given only as 1 mole. So what happens is this bromine goes out and this chlorine also goes out as a free radical formation is taking place here like this. So these two radicals will pair up to form a compound like this, okay. So this is a scenario when this is mentioned only as 1 mole or products are not like these, then you can say A is not mentioned or B, C, D are not mentioned. So you can go to option which is having this kind of answer, okay, right. Yeah, next here we have few more questions. Look at this. The compound which will have the lowest rate towards nucleophilic aromatic substitution and treatment with OH minus. So nucleophilic substitution means what? One nucleophile has to go out, the other one should enter in right now. So now that will be more readily takes place when it creates when the substrate is having more electron deficiency at the nucleophilic substitution center. Okay, so what are the sites here which can undergo reaction here? Wherever we have halogen, that will be the reactive sites here. So chloride ions will goes out. So in the place of chloride ion, we will get this OH minus in. Okay, so for example, I am writing here. Electron withdrawing group, and here I have OH minus. So now what happens here is, this OH minus will attacks at this carbon center and chloride ion should go out. Okay, so when it is possible, whenever we have electron withdrawing group, so that will take the electron density from the ring towards itself, creates more positive charge here. Therefore this nucleophilic attack is readily or easily takes place. So that will be the scenario when we have more electron withdrawing groups, more will be the reactivity right now. So where do we have more electron withdrawing groups? See, we have 2 nitro groups here, that makes it more electron deficient. Therefore reaction takes readily in B. Okay, and after that, here we have ortho position, here we have meta position, para position. So we know para position it will be more effective, okay, and even in C also it will be more effective as it is very near that is at ortho position itself, and they are asking which is having slowest rate. So it will be fast in C, A, B, but it will be slow in D. Why in D? Because at meta position there is no mesomeric effect now, just we have minus I effect, which means that will be the least effect. We know right now the effect of minus I will be relatively less when I compare with the mesomeric effect right now. So therefore the nucleophilic substitution will be having very slowest rate in option D, okay, as it has no electron withdrawing groups either at ortho or para positions, okay. Your option D will be very suitable answer here, right? Right. Next. So tell me what is the answer for this particular question. What is the major product formed in the given reaction? See, we have KOH in alkali medium, in alcoholic KOH is given. So alcoholic KOH under heating condition undergoes elimination reaction. So just by looking at the reagent and given conditions, you should understand what type of reaction and you should predict the product as per that. Okay, elimination reaction is taking place here. So what kind of elimination we can expect? See, here we have, this is the alpha position where bromine is there. Definitely here dehydrohalogenation takes place. It means one halogen and one hydrogen should removed from the given, eliminated from the given substrate. So we have alpha position here, and this is beta and this is also beta. So at beta position we have hydrogens. But which hydrogen has to be removed from which beta position? So I am saying this is beta 1, this is beta 2. So product should form in such a way, the resultant one should be more stable. The product should be more stable, alkene. Okay, so more stable alkene will be formed when it is in conjugative system. Okay, see here, if I remove this beta 1 proton, so that we will get a product like this, and along with that here it is like this. Okay, so this is the product possible as a one type if I remove this proton, and the second type I can remove proton this side, proton this proton, and I can get a product like this. Okay, we will get a product like this. Okay, so but which is major here? So first one will be major and second one will be minor here. So why it is major? Because when I remove this proton, beta proton, and this halogen from alpha position, we will get a double bond here which is in conjugation with the ring pi electrons here. This ring electrons and the pi bond formed here are in conjugative position right now. That makes it to be more stable. Therefore our option B will be perfect answer for the given question. Okay, so B will be your answer for the question, right? Screen is blur. Okay, now it is fine, I think so. Yeah, so next question here we have, tell me the correct stability order of the following diazonium salts. See, diazonium salts are the compounds having nitrogen triple bond like this. Okay, and this nitrogen is having positive charge, and salt they are saying one anionic part, like so diazonium, sodium, diazonium chloride, I can say this is what diazonium chloride. Okay, so now this is salt. So this diazonium chloride will be more stabilized when it has electron releasing groups. When it is having any electron releasing group attached to the ring, so that will releases electrons and makes this N triple bond more stronger and more effective, as nitrogen is having positive charge. Okay, so if this group is electron withdrawing group, what happens if it is electron withdrawing groups? Already nitrogen is having positive charge. Now this electron withdrawing drags the electrons towards itself and makes the nitrogen as more positive or more electron deficient, which results to be instability right now or destabilize the system. Therefore the one which is having electron releasing group is more stable. See, here we have electron releasing group, therefore it can releases electrons like this, therefore that makes it more stable, right? Yeah, so A is more stable. After that, see, we have nitro group here and cyano group here. So both are electron withdrawing groups, but stronger electron withdrawing group is nitro group here. So it makes it to be highly unstable from the given 4 options. So B will be least here, and after that D, and in between C. So A, C, D, B will be your answer. So for option B will be your perfect answer for the question. Hope this is also clear, right? right? Yeah, if these things are clear, just click on the like button first. Shahid, just look at the screen, you will see everything. I mean, on the thumbnail you will get every data about me, or in the description box you can look. Yeah, next here we have few more questions. Yeah, tell me Ka and Kb of this two weak acid and a weak base is given, and they are asking pH. So how can you find the pH of this kind of salts, salt solutions? Very easy. This salt is formed from the combination of a weak acid and a weak base. Okay, so therefore the resultant salt solution pH will be calculated using pH equals to 7 plus half into pKa minus pKb. That's it. So how do we get pKa, pKb values here? See, Ka values is given as 10 power 1.8 into 10 power minus 5, and Kb value also given same value. Therefore, if Ka, Kb are same, then their pKa, pKb values also same right now, because they have same formulas. Okay, so like pKa means minus log Ka and pKb means minus log Kb right now. So it means pKa, pKb values are same, therefore pH equals to 7 plus this becomes, overall it becomes 0. So 7 will be, pH will be equals to 7. This will be your answer. Okay, and I will be showing you few more questions here. Just look into these questions. Yeah, so these are the questions that I have discussed in the last session. It means day before yesterday's live session. Okay, so in the previous live session I have discussed this. Now you just give a try for solving all these questions. If you are really facing difficulty, just go and watch the sessions and get clarity over these questions also. Okay, yeah, so this is about the session. If you have any queries, feel free to ask me in the comment box. Okay, so this is about the session, and I hope you have got something new in the session. And if you are having any doubts or any topics to be discussed from our side, just feel free to write in the comment box. We will be looking into it. Thank you for watching. ఎవర్రా బాబు ఇట్లా